Hi, in this video I'm going to show you some of the example problems that how you can convert the position vector to force vector and then find out the resultant of multiple force vectors. Okay, so to do that I'm going to show you the problem from F2-23, and you can see I have two forces here, one from A to C, and the magnitude of that force is 420 Newton, and then I have another force working from A to B, and the magnitude of that force is 840 Newton. Now I have to find out the resultant of these two vectors here, two forces here actually. So you can remember the first thing we just try to find out the position vector. To find out the position vector, actually we have to know the coordinate of these points here. Let's say for here, for point A, you can see this is our z-axis. So x and y equal to 0 and your z equal to 6. So that's basically 0, 0, 6. Then the position or coordinate of B, you can see for 3D cases actually this is your x-axis, this is your y-axis, okay? So you can see in the x-axis this is 3, y-axis is -2 because that's the other side, positive side is this way, if this is this side, so this is -2, 0. Similarly, C is actually x is 2, 3, and 0. Once we know the coordinate, then basically we can start writing the position vector. So let's say for A to B, the position vector from A to B, that would be from B minus A, right? You can remember that formula that xb minus xa I plus yb minus ya j plus zb minus za k. So we can show that one here. So b minus a, xb minus xa, that's actually 3i plus b minus a, that's actually -2, and 0 minus 6, so that's actually -6. Okay. Once we get that vector, then basically we have to find out the magnitude of that vector so that we can express that one to unit vector, okay? So that's why we need to find out our RAB, the magnitude of that vector, which is basically that's actually 7. So the unit vector for AB, that would be actually 3 by 7i minus 2 by 7j minus 6 by 7k. Now our force vector would be force from A to B, that is basically FAB multiplied by UAB. So the magnitude of FAB is basically 840. So if you multiply this one with 840, then basically you get 360I minus 240J minus 720. Okay, that's your force vector AB. So now we have to find out the force vector from A to C again, right? So I'm going to delete that one and then try to find out the I'll just keep this one here, okay? So my position vector from our A to C would be C minus A. So you can see 2 minus 0I, so 2I, 3 minus 0, J, and 0 minus 6, so 6K. So the magnitude of RAC, which is basically the length from A to C, again that's equal to 7. So you can see your unit vector from A to C, that has to be 2 by 7j, 2 by 7I plus 3 by 7j minus 6 by 7. Okay. So again I can get the force vector FAC, that would be the magnitude of that force, 420, so FAC is 120 I plus 180 J minus 360 K. So I already have both this, like vector here and here. Now if I want to find out the resultant of these two vectors, then basically I have to just add the I term, J term, and K term, right? So you can see the resultant vector, that would be 360 plus 120, that's 480I. Then if you add these two, that's actually 420, right? No, sorry. That's negative 60J minus 1080 that's basically the resultant of these two vectors. Okay? Okay guys, now we are going to solve problem number 2-92. Okay, you can see the figure here. I already drew that one. This is your y-axis, this is your x-axis, and this is your z-axis. This is point A, this is point B, and this is point C. So I have two forces working from A to B and then from A to C. I have to find out the resultant vector and then find out the coordinate angles of the resultant vector. Okay, so as usual, let's try to find out the coordinate for A, B, and C. So you can see for A, coordinate of A, you can see this one is in this direction, right? So that's your x equal to 0, y equal to minus 0.75, and z equal to 3 meter. Now what about B? You can see B, this one is 2 meter and this one is 40 degree. So if you take 2 cosine 40, then basically you get the x-axis, right? So this one is 2 cosine 40, then 2 sine 40, and z is 0 here. Similarly, we can find out our c here, which is in the x direction 2 meter, y direction minus 1, and z equal to 0. So 2 minus 1 and 0. So here actually I can change that one, putting the value of like cosine 40 and sine 40, and actually I get that value 1.53. Sorry. So once again, we'll try to find out the position vector first, and then basically we'll convert that position vector to force vector and try to find out the resultant, right? So the position vector for A to B that would be B minus A. So 1.51 minus 0 I, then 1 minus 29 minus, let's say, I'll just write that one, 1.29 minus, and again minus 0.75, J, and 0 minus 3K, which is basically 1.51 I plus 2.04 J minus 3K. So once again, we can find out the magnitude of RAB. Which is basically 3.94. So the unit vector for AB, that's basically RAB divided by the magnitude of AB. So you can see 1.51. J minus K. So if I want to find out the force vector, then basically I have to multiply that one with the magnitude of the force, right? So FAB is nothing but FAB, the magnitude multiplied by your unit vector AB. So if you multiply whole thing with the magnitude FAB equal to 250, so that's basically, if you simplify that one, then you get the FAB. Let me write it down here. .3 129J minus 191K. Okay, now what we are going to do, we are going to express that AC into the force vector, right? So to do that, so RAC you can remember the formula, you have to subtract from C to A, right? So 2 minus 0I plus minus 1 minus 0.75. So J and then 0 minus 3 K. So this one is basically 2I minus 0.25 J minus 3K. So we can find out the magnitude of our AC, which is basically 2 squared plus minus 0.25 square. So our unit vector AC, that has to be AC divided by the magnitude of AC, right? So this one is nothing but 2 divided by 3.61 I minus 0.25 divided by 3.61 J minus 3 divided by 3.61 K. So I can definitely express that one in force vector now. So force vector AC would be equal to magnitude of AC and then multiplied by the unit vector AC. So that would be 400 Okay, so if I simplify that one, let me write it down here. So FAC is basically 221I minus 27.7 J minus 332 K. So now if I want to find out the resultant of these two vectors, then basically I have to just add the I term, J term, and K term, right? So if I do that one, so if R, the resultant vector, that's basically 97 plus 221, that's 318. I minus, no, actually plus 101.63 J and then minus 522.58 K. So that's basically the resultant vector. Now if you want to find out the magnitude and the coordination angle with x, y, and z axis, then basically we have to find out the magnitude like this way. So if R, the magnitude of that vector would be 318.67 square plus 101.63 square plus minus 522.58 square, which is basically 620 Newton. That's the magnitude of this resultant vector. Now if you want to find out like the coordinate angle, then basically it would be much easier to, if you express this vector as a unit vector, okay? So if you want to find out your U resultant, that's basically 318.67 divided by 620 I plus 101.63 divided by 620 J minus 522 divided by 620 K. So basically this is your cosine alpha. This is your cosine beta. And this is your cosine gamma. Okay? So what would be your alpha? So alpha would be cosine inverse 318.67 divided by 620. That's basically 59.1 degree. Beta equal to cosine inverse of this one, 101.63 divided by 620. That's basically 80.6 degree. And gamma is cosine inverse minus 522.58 divided by 620. That's actually 147 degrees. Okay, so the resultant vector that makes 51.1 degree with the x-axis, 80.6 degree with the y-axis, and 147 degrees with the z-axis. Okay, now let's move forward and try to see one more problem with a little bit different test. Okay, now we are going to solve problem number 2-89. This one is a little bit different in that sense that they gave you the force vector that's working from A to B, and they said like the distance between A to B or the magnitude of the position vector is 9 meters, and they're asking you to find out the location A, X, Y, and Z. X, Y, and Z. You have to find out the location. So what you have to do now, we have to do the other way around. Like usually they give you the location, from there you find out the position vector, then from position vector to unit vector, and when you multiply the unit vector with the magnitude of the force, you get the force vector, right? So actually we have the force vector. So what is the magnitude of the force here? So if so that's basically your magnitude of this force vector. Okay? Now if I want to find out the unit vector from A to B, that's basically divided by the magnitude of this vector, which is 350 If you simplify that one, you get 0.56 I minus 0.4016J minus 7229. Okay. So you can also remember that, like, if you multiply with the magnitude of this formula here, you know that your UAB is basically your position vector AB divided by the magnitude of the position vector, right? So you can find out this RAB, which is nothing but UAB. You multiply that one with the magnitude of the position vector, right? So I know that RAB equal to 9 meter here. So the position vector is basically 9 multiplied by 0.5623 I minus 0.4016J minus 0.7229. Okay, so that's nothing but actually 5.06 I minus 3.61 J minus 6.51. Okay. Now you can also see the location or coordinate of B is 0, 0, 0. So if I want to write the position vector based on the coordinate, so RAB, that would be actually x minus 0 I plus y minus 0 j plus z minus 0 k, which is actually xi plus y j plus gk. Again, you also have the position vector is this one. So if you compare this one with this one, then basically you can find out that x is equal to 5.06, y equal to minus 3.61, and z equal to minus 6.51. So this is the answer here. Okay, so the location of A is 5.06 minus 3.61 and minus 6.51. Okay, thank you.